Welcome to 24 Hours of PaaS, Growing Our Community. We're excited you could join us today for Scott McCormick's session, Azure Internet of Things, a practical introduction to Stream Analytics. This 24 Hours of PaaS event consists of 24 consecutive live broadcasts delivered by up-and-coming speakers and experts from the PaaS community. All sessions will be available next week on www.24hoursofpaas.com. My name is Bob Pusateri. I'm a DBA and co-leader of the Chicago SQL Server user group. I have a few quick introduction slides before I hand over the reins to Scott. Scott will speak for 40 to 45 minutes, and then we'll move on to the Q&A where you can ask him any questions you might have. If you're having any issues, just type your question into the question pane on the GoToWebinar control panel and someone will assist you. To maximize your screen, use the Zoom button located on top of the presentation window. Feel free to enter your questions in the Q&A field at any time. The questions pane is located on the right side of your screen. Once we get to the Q&A portion of the session, I'll read off your questions to the speaker. Since all attendees are muted, you will need to submit questions by typing in the Q&A field. Note that there will be a short evaluation at the end of your session. Your feedback is important to us, so please take a moment to complete it. It will show up on your screen. I'd like to take a moment to thank our presenting sponsors, Microsoft, Cisco, and Dell Software. In addition, I'd like to thank the support sponsors for this event, SQL Sentry, HP, and SolarWinds. The staging of 24 Hours of PaaS would not be possible without their support and dedication, and they are the reason this event is available free of charge. Next, I'd like to bring your attention to the upcoming PaaS Summit. Taking place in Seattle, Washington from October 27th to the 30th, PaaS Summit 2015 will feature over 200 sessions with world-class SQL Server experts. Planned and presented by the SQL Server community for the SQL Server community, PaaS Summit is single-handedly the largest gathering of SQL Server and BI professionals. With over 5,000 attendees from all over the world, PaaS Summit is also a great place to network and meet face-to-face with experts, peers, and MVPs. More importantly, PaaS Summit delivers on providing you with the answers to your SQL Server issues, along with the knowledge, strategies, and skills you need to stay ahead of the curve. Contact your local chapter for a discount code to save $150 off. Optimize your savings by registering before the end of Sunday, July 12th. To find out more about PaaS Summit, visit www.paassummit.com. And now, please let me present the speaker of the hour, Scott McCormick. Scott is the principal consultant with Pythian. He has 11 years of experience on SQL Server and specializes in production support, development, and data architecture and data modeling. And now I will hand off to Scott.
Great. Thank you. So yeah, this is the Azure Stream Analytics presentation. We're going to cover the Azure Internet Stream Analytics and how it works. And then we're going to go into a real-world example at the end to show the entire process coming together. We're going to go into some fraud detection over phone systems. So, the Internet of Things. What is the Internet of Things? Internet of Things is a world where billions of smart, connected devices speak to each other. And from our end, the data gathered from those interactions gets you valuable insights into how your applications are being used, how the hardware they're connected to are being used, and how your customers really use your products. So the Internet of Things, it's not a new concept. MIT predicted it almost 20 years ago, but it's now at a critical point. This is because, number one, hardware is cheaper, so microchips, GPS sensors, accelerometers, any of that kind of stuff can be placed on almost every 5 minutes they send data back from their mattresses on what position is the mattress in, how much pressure is on it, when's it being used, what time of day is it being used, and that information just goes back to their system every 5 minutes. Obviously cars, refrigerators, none of this stuff needs a lot of RAM or CPU. We're just sending small unstructured data back to the system, so JSON data or maybe a little bit of CSV data. the software is more advanced. Connectivity is obviously a lot faster. And then nowadays we have Azure and other cloud providers who give us, the boost projects. So you can just, start up a VM or start up some sort of, in this case, Stream Analytics job, and do a little project and see what happens. And if nothing comes out of it, just shut her down. It's not a big deal. And if the benefits start to come in, then you can put a lot more money. Right now in 2014, we had 2 billion smart devices shipped. That's expected to go up to 75 billion devices by 2020, and all of those can be sending data back to some sort of cloud or Stream Analytics device. It's expected to have an economic impact between $2 to $6 trillion. That's based on a McKinsey Global Institute study in May 2013. And it's not so much the Internet of Things, the Internet of Things, the devices, your computers, your systems, and your data centers, and your applications and hardware that you're sending out to your customers that you're able to dig through and really use. So that's the Internet of Things, and then Microsoft has developed this Stream Analytics as fitting into that and helping you dig through the data that's coming in. So what is Stream Analytics being used for? Who's using it? You've got personalized real-time stock trading, time detection, reliable ingestion analysis of data generated by sensors, website clickstream analysis, and real-time CRM management. So imagine a client of yours has a customer site where the shelf is running out of room and or running out of stock rather. That gets sent back to the Stream Analytics job, which processes that, sends it to a technician with a tablet. He's able to restock that shelf within 24 hours and really make sure it stays fully stocked at all times. So some more in-depth examples, we have things like vending machines, the vending machine being the application or device on the left here, sending data through a gateway up to an Azure Event Hub. Sending stock levels, machine temperature, status, gets processed by the Stream Analytics system and then fed back to the machine to overheat, whatever it is, and go deal with that immediately. For real-time log analysis, where we're pulling data from SQL Server error logs or Windows event logs or anything like that, and processing it and putting it up on the dashboard for a NOC or somebody to see. And then data archiving, where again you're just pulling from flat files or database files and then putting them into Azure Blob Storage for long-term storage and processing later if you ever need to run reports or anything off of that. So Azure Stream Analytics, what it is a real-time scalable analytics engine that's used to process millions of events per second with no data loss. Once the event that you're sending from your system gets up into Microsoft's Azure network, they guarantee you will not lose that data unless it ages out or something else, which are things that are all configurable on your end. So, and then why use Stream Analytics? There's a few reasons. One is ease of use. You'll see later on when we're creating this process, it's very SQL-like query syntax. There's only a couple of special things that it needs. Very low latency. Once the event gets up into the Azure system again, it's sub-second response time end-to-end until it's in your data store or wherever it's going to end up going. It's extraordinarily scalable. We handle up to 1 gigabyte per second of data. And when you think about these messages, like I said, it's just a JSON or a little CSV burst. It might be 1 kilobyte at the most. So you're really talking about millions and maybe even billions of messages that could be handled per second. And very reliable. They used Hadoop, Yarn, and Reef for scaled out processing. So if one of the engines that it's running on goes down, it doesn't matter. There's a whole farm of them out there that are running and able to handle your processing. So there's very little risk of it going down. And really what this whole deal is, you just describe the transformation in a SQL query language that you want to take place to this data, and the Stream Analytics handles automatically distributing the workload, the performance and resiliency, and it really eliminates the need for a lot of the procedural programming that you see in a lot of these stream processing solutions and a lot of the competitors to Stream Analytics. And finally, some people, sort of ask about why, what is the difference between Stream Analytics and big data. The way to think about it is big data is just a giant pool of data that you can dive into and look at whenever you want, but it's just sitting there not doing anything. Stream Analytics is actually data in motion. So it's, as compared to looking at a pool, you're looking at a river where the data is flowing by constantly. And so to take that into account, there's special time components and windowing functions within Stream Analytics that are required to process it correctly. So at a high level, Stream Analytics in Azure has four pieces to it. The first one is the producers. These are the applications that are running on your customers' systems or on the Android phones or on the tablets. These aren't provided by Microsoft. This is where 90% of the work is probably going to go into from your perspective, is that you have to develop these producing applications. You can send a message up to Azure either through HTTPS or AMQP, whichever one you want. But this is where 90% of the work is done, more than likely on your end. Then they have ingesters. These are event hubs or Azure Blob Storage. The event hub, it's a very fancy queue with some partitioning and other logic in it, and it gives you some date time information. It's used for real-time data that's coming in. This is where you have your event log reader that's sending the data up. It connects to an event hub. The Azure Blob Storage is used for historic data and slowly changing dimensions and things of that nature. So. And then the third piece is the actual transformers. This is the analytics job that's going to be running and pulling the data out and making it look however it needs to look for your output. And then the consumer group subscribes to the analytics job. Generally, you can have multiple subscribers per analytics job, but usually up to 20, or up to 20 are allowed. And these are, Azure Blob, SQL databases, things like that. So this is the high level. These are the four pieces that are required for successful Stream Analytics. And when you look at the actual Stream Analytics job, the way it works, and this is really the engine that this whole thing is built around, Stream Analytics job runs and it queries the input. Queries the inputs. This is querying the event stream that's coming in. You define sort of a tolerance for late arrivals and things that are out of order and how it handles that. But for the most part, it just goes out to the event hub, pulls the data in, and using a SQL-like syntax, you run a select statement against this event hub effectively. And then it writes this data to an output file after you've queried it. So it reads the data, organizes it, adjusts the events, and then puts it into whatever the output is. And the output can be any of these five guys right here: Azure SQL Database or table storage. Obviously, Azure SQL Database and table storage is if you need to put the data into some sort of relational format for further querying, running reports, whatever you need to do. Blob storage for long-term archival of the data. Of course, Azure SQL Database can only get up to 500 gigabytes at the most, so if you're going to have more than that, you're going to be required to use blob storage for some of this. Another event hub, you're welcome to put it into another event hub if you're going to be sending the data to, this is when you need to send it out to a tablet or send it to some other system for further processing. You would put it into an event hub. Or if you're combining a bunch of different streaming pipelines together. And then last is obviously Power BI. I don't know if people have really played around with that or not. It's still in preview mode right now, but it looks like it's a nice little reporting utility that they're going to throw out there for everybody to use. So, all right. So when you create a Stream Analytics job, the main piece of it, as I mentioned, is the Stream Analytics query. You can only do queries. It's SQL only. It's pretty much 100% regular syntax with just a few special functions for time analysis, and those are what are in red here on the right. And you can see in the from clause, the first one we have is the timestamp by clause. So timestamp by, when you define your event stream, or rather your input source, and the Stream Analytics job needs to go and query it, it needs to know what order are these events going to be in. The default, if you don't use the timestamp clause, is just the time that they showed up in the event hub, whenever that may be. But you may want to use, this is when the event occurred according to the machine that's sitting on, or this is it in GMT time, or some other sort of date time logic that makes more sense for you. And that's when you use this timestamp by date time column, whatever the date time column within your data is. The second special function is here in the join. The joins have to be temporal, so you can see in my example I've got the red and date diff seconds between 1 and 5. That defines the limit of how far two events can be separated. So if you don't use this kind of logic, and the Stream Analytics won't even run without it, but if they didn't have this kind of logic built into it, effectively you'd be looking at an infinite number of events. You have your event hub has been up for 3 months and running, and it's got 7 trillion events that have processed through. There's no way it can take this particular new event that came in and try and join it on another event stream going back that far. It's just not really possible. So you need to use a date diff where you define this event related to, in this event stream, related to this event stream, but only for the past. In this case, in this example, it's been 1 to 5 seconds. Could be 1 to 5 minutes, 1 to 5 days if you need it. It's just however far back you need to go. The only time you don't need to use this temporal logic is if it's a reference table in Azure Blob Storage. Reference tables in Azure Blob Storage, like I mentioned, are slowly changing dimensions and historical data, so the assumption there is that it's not going to change very often, and it will be able to scan that entire thing. And then the last piece with the time logic is in the group bys. They use window functions, windowing functions. They aren't exactly the same as the window functions within SQL Server. They give us 3 of them. We'll look at them on the next slide, but there's this defined window of when it should group by. So going into windowing functions, this is effectively what it looks like. You define a window in your group by of 5 minutes, and then say group by this column, every event within 5 minutes, and that's what it's going to do. So it'll sum up the values, put them in there 4, 2, 12, as you can see in the example there, and move on with its life, 5 minutes, 5 seconds, whatever. And you get 3 different options on this windowing function. The first one is the tumbling window, which is a fixed time frame, one after the other. My window is 5 minutes, the next window is 5 minutes, the next window starts immediately after that, and it's 5 minutes. And that's for when you know exactly what your window should be on a fixed time frame. The second one is a hopping window that gives you an overlapping time frame and a little bit of latency built in. So my window is 5 minutes, overlap with the next one by 10 seconds or by 1 minute or whatever you feel comfortable with, because the machine is sending in data a little bit late and we aren't so sure about it. And the last one is a sliding window. I don't have a little picture for this one. The sliding window is, your window is 5 minutes long. You have an event comes in at 5:30 at night. That's the start of the window, is the event entrance. That's event A. Event B comes in 4 minutes later. Event B, when it enters, starts a new window, but it also gets included in the previous window because it's 5 minutes long. When event A exits 6 minutes after event B enters, that's another new window, and event A exit is not included in that summary. So it's a flexible time frame based on when your events come in, and there you go. So the billing model for this whole thing. So event hubs, you have either the basic tier or the standard tier. Obviously do the math. It depends on how many events you expect to be processing. Certainly to start out, most of us would be on the basic tier at 5 cents per every million operations. Otherwise the standard tier, $10 a month for 12.5 million, and then 80 cents, 50 cents, 20 cents as you climb up the pyramid from there. So that's the event hubs, and then the Stream Analytics process is built in terms of streaming units. This is how much computing power it takes to process your Stream Analytics job. So you get 1 megabyte per second or 1,000 events per second in, 2 megabytes per second out. You start off just with 48 units, and right now they're charging at 3 cents per unit hour. So it's pretty much, it goes one standard account with 48 units across all event hubs, but it's only a single event hub really only needs 1 unit. So that's about 48 event hubs that you can deal with without changing anything. Okay, so here's our example. We're going to walk through building a Stream Analytics process, and what this is going to be is I've got just a little .NET application running on my computer that's generating fake phone records and sending them up to an event hub in Azure, and we'll create a job to process them. And what we're going to be looking for is fraud detection. So somebody with the same SIM card on their phone calls a number in Germany, and then 5 minutes later calls a number in the United Kingdom. That's obviously impossible, so we're looking for potential fraud detection within the stream that's coming in. So here we go. I've already created all these things. I don't know how much you guys have played around with Azure, but everything takes 2 or 3 minutes, so everything's already created. We'll just walk through how it works. So the first thing we do is create a event hub, which is under the service bus here in Azure. And the easiest way to do that is click New, go to Service Bus Event Hub, click Create, give it an event hub name, give it the region. Whatever region you choose, you definitely want your event hubs and your Stream Analytics process to be in the same region, so you don't spend money transferring the data back and forth. And you either already have a namespace, or it'll automatically just assign one for you. So here we have our event hub that I've created. And then we can come here and configure it. This is where we define the amount of messages that we're going to retain, whether the event hub is enabled or not. If you do the quick create, it gives you 16 partitions by default. That can be changed. And then our shared access policy, you can do manage, send, listen. I've just got a regular default administrator here, and then our keys for the .NET application to be able to generate and connect to it. Then you define a consumer group. Every event hub comes with the default consumer group. You definitely want a separate consumer group for every application that's going to be connecting to this event hub. It helps with contention and making sure that nothing hits anything else. So we create the event hub. The second thing we create is our producer. So this, like I say, this is what you create in-house. This is my little .NET app. I don't know how well it's showing up on the presentation here, but it's just a bunch of random JSON data that's being sent up, a bunch of phone numbers and locations and things that's going out there. So you have your producer sending the data to your event hub, and then the next step is to create your Stream Analytics job. The first step for the Stream Analytics job is to create your inputs. So you can see here I have my data stream input and my reference data input. The data stream is what's being sent from my .NET application we just looked at, going to the namespace, using the administrator login, using this particular consumer group, and I'm sending up JSON data. You have your choice. You can send JSON, CSV, or Avro. If you send CSV, you can send comma, semicolon, space, whatever you want there. And of course the encoding UTF-8, and Avro is Avro. So I'm sending JSON data up, and then I have my trunk references. This is the reference data that I'm using, this is just a CSV file that's sitting on Azure Blob Storage. There's nothing special about it. It's also JSON data, and it's UTF-8, and again, this can be JSON or CSV. So think of your inputs, do more than think of it, treat them exactly like tables, in that when you query them, you just put them in the from clause, and that's where they go. So, the second thing, after you define your inputs, you come here to your query. I'm sorry, we missed a step. After you define your inputs, particularly after you define your data stream and have data coming to it, there's a sample data button down here at the bottom, and what this will do is give you the last 10 minutes worth of data that went into the Event Hub, and you can use this to play around with and test your queries as they run. It's going to be a lot faster, and there's no other way beyond writing the data to an output to actually test it. So you definitely want to get the sample data. It just generates a file in JSON format that you can then query later on. I've already done that, again, as I mentioned, so we'll have that ready to go. So here's our query. This is the query that we're going to end up with, is on the screen right now, but we're going to start off here with this query, just a very simple select star from real-time phone stream. Real-time phone stream, again, is the name of the input that we just created. When you come here and say test with our real-time FOD stream JSON file, which was generated by the sample data. Okay. Take a minute to upload it. And just scroll down a little bit, and you can see it gives us an idea of what the data looks like and what we're dealing with here. It does only show 10 of the 25 columns that are available. So if sort of the assumption is you know what your application is sending up to this Event Hub, but if you ever need to know, you can just go to any online JSON parser and just run it through here, and they'll show you very simply, you know, these are all the columns that we're dealing with here. So it's not really very difficult to find. So that's just obviously a very simple query. So this next query we look at is going to be using a tumbling window. There it is. So what this is going to do is select, it's going to use the system timestamp, which is the built-in function within this to give us the current time. It's going to use the switch number. Again, this is a phone system, so there's phones, switches on the phones and things, and it's going to count the number of calls coming from a particular account, and then it's going to group them by only the ones within the past 5 seconds and coming from any particular switches. We rerun this query, and here's what we get. I'll scroll down to where there's a little bit more interesting data. So you can see here at 18:08:50 in the US, we had 3 calls. 5 seconds later, 18:08:55, again US switch, we had 5 calls. I mean, it's a very simple group by without a lot to it. And here we're giving the timestamp by the call receive time. Again, if we didn't have this, it would be the time that the event showed up in the Event Hub, the time the data was sent from our producer. And then finally, the super exciting query that we'll be using is, this is our fraud detector here. So again, it's getting timestamp, getting some columns, then we're taking our real-time phone stream, timestamp by call rec, and we're joining it to itself on the IMSI value, which is just effectively a primary key. And then here's again our temporal part of the join, where the date diff using seconds between S1 and S2 is between 1 to 5 seconds. Again, this could be DD if we want a day, I suppose, or minutes, whatever it is. And then our where clause to say where the switches are different, so that it's not, so that it has to be from a different country. Rerun this, and this is the query output. So here we have, again, Germany, United Kingdom, 5 seconds apart. So potentially this is the kind of thing that we would want to give to some sort of authority or somebody to look into and prosecute, do whatever you want, I suppose. We're going to discard changes. And all I'm doing, and then I've defined my output, all I'm doing is putting into Azure Blob Storage. Again, this could be, a SQL table if you want. The only thing to know is make sure the column names match up and data types. It can be a table storage. It can be another event hub. It's not really a big deal to set any of those up. So here we're just putting in the blob storage with a prefix of fraud, again, JSON, CSV, or Avro, UTF in either line or into an array. Finally, after you've set up your inputs, your query, and your outputs, this is where you define the streaming units. Again, this is where you get billed on. So you want this to be, you need to look at how many units you expect to, or how many events you expect to process versus how many streaming units you really need to get it done. I recommend starting at 1 and going from there. You can get up to 48, and if you need more, send them an email. Do whatever you want. And finally, you configure here. You have your late arrivals and out-of-order arrivals. So you have a machine somewhere that doesn't have very good internet connectivity, or it goes down for a while and just sends everything up as a batch. Whatever is happening here, you just define your tolerance, 5 seconds, 3 days, whatever it is. And again, for out-of-order tolerance, however minutes or seconds. And then what do you want to do? Do you want it to adjust it? Do you want it to just drop the value and move on, or do you want to try and fix it and stick it into the event hub where it should go? This all depends on the kind of data you're working with and how important it is to you that every single thing gets put through. So there's that, the locale, and then where you want to keep your monitoring kind of data. And that's it. Then you hit start, and you get 3 different options. So when the very first time you start it, you just get job start time and custom time. I've done this obviously before, so I get last start time. So what this does, it tells it what events should I ignore. So if you say job start time, any events that came in prior to the start of the job are immediately ignored, and it just moves on with its life. If you do a custom time, you can define what time the job should start, and again, any events that come in before that are ignored. And then last stop time, this stopped at 3 in the afternoon. We had to make some changes, but I don't want to lose any of those events, even though now it's 6:30 at night. So, go from the last stop time. So here I'll just say job start time, say OK. This takes a few minutes to start up usually, anywhere from, it says several minutes. I usually see it take about 5 to 10 minutes. So for that, we'll come back to the monitor, and we'll be able to see the data go through. I'm sure most of the people on this call are familiar with Azure's monitoring. This is also where you can configure alerts. My output events are too high, whatever. When you make an alert, your only option is to send an email. So, make it good. Make sure somebody's on the other end of that. This is important to you. And that's everything. So I think I spoke a little too quickly, but we'll come back to the monitor. But for right now, if there are any questions, let me know.
So at this point, we have no questions in the queue. If anyone has any questions they'd like to ask, feel free to type it into your Q&A window on the right side of your screen.
Yeah. Okay. So it looks like monitoring is not going to show up after all, but in any case, you can play with this. It's very simple, and it shows you all your different errors that are happening. So, so if there's no questions, then it sounds like we can move on. Well,
Hang on, actually, we just got a question here. Actually, what is the speed like for transferring to Azure SQL database for output? They specify.
well, I don't know the limit on how many transactions or how many events you can slam into an Azure database at one time. What I've never gotten it up that fast. So you know, I go off of they can put, you know, they can process millions of events per second. I don't think, you know, at the end of the day, a SQL Azure database is a SQL instance that's just sort of sitting there at the end of a endpoint. So I believe it'd be able to handle that much data getting slammed in with no problems. So, but I can't give you a specific number. I've just never seen it have struggle with putting data in.
All right, and that's the only question we have. So if there's nothing else, we'll go ahead and close things up here.
Great.
Thank you very much for attending Azure Internet of Things, a practical introduction to Stream Analytics. I'd like to thank Scott for his time and his expertise. Again, I'd like to also thank our presenting sponsors, Microsoft, Cisco, and Dell Software, and our supporting sponsors, SQL Sentry, HP, and SolarWinds. We hope you enjoyed this session as much as we did. Follow along on social media at PASS24HOP and share your thoughts on the event with hashtags PASS24HOP and SQLPass. Stay tuned for our next session, The Art and the Science of Designing a Mission-Critical SQL Server Solution with Maxwell Myrick, happening in a few minutes.